I'm Sam. Normally when I give these talks, I often do a very similar thing, so I'm not going to do that today. If you want to know more about the background of what I'm going to talk about, there's tons of videos on YouTube, so I recommend you go and just watch those. Today, I'm not going to spend too much time talking about how and why I've started this project. What I'm going to do is just try, because you're all programmers, right? How many of you are programmers? Brilliant, right. How many of you have played with Sonic Pi? Oh, that's lovely. That's growing every time I give one of these talks. What I'm going to do in this talk is just dive in, if that's okay. Because often when I watch my own videos back, it's obviously pretty horrendous to watch your own videos. But I always think, why have I spent so long talking and before getting to actually the coding? So I'm going to spend very little time talking. I'm going to spend more time coding. Is that cool? No? So this is, I'm not finished yet. Hold on. Wait. That's great if you just remember that for the end. I'll give you a moment to do this. So here we are. This is the website. It's got some crazy effects. There must be some sort of cloud system going on. Go to here if you want to, when you enjoy what I'm doing, you can go to this place, download the software. It runs on Windows, runs on Mac, runs on a Raspberry Pi. If you have one, it's installed by default, but I always recommend updating to the latest version of Raspbian. And also, if you're a Linux person, it's much harder, but there is a way of getting it installed. The problem with Linux is there's no Linux, is there? There's Linuxon. There's lots of different Linuxes, and so supporting it is a terribly difficult task. And especially with music and audio, Linux is not the most straightforward. But if any of you Linux people out there like audio things and like to give me some help, I'd love some support. So that's to bear in mind. But certainly with a Mac or a Windows machine, you get the simplest way of starting. You can read some things, you can find out what we're using for the classroom. We have a community, which is great to get involved and talk to. And this community is not programmers. There are some programmers, but there are educators on there. There are artists on there. There's musicians on there. It's a lovely place to actually share your ideas. It's super friendly. There's no right or wrong questions. Just get involved and ask questions, and you'll get support from lots of different people. There are people making performances with it. I've given talks. So watch this talk if you want to see the background. Okay, read a book. Here's some examples, but that's boring. What's actually the code? If you download Sonic Pi, this is what you'll see. Right, so this is the editor. It's just a text editor. Has Emacs shortcuts, if that's useful to you. If not, I'm terribly sorry, but you need to learn Emacs shortcuts. Or you don't need to use the shortcuts at all. And you get a text editor. There's a log to say what it's doing, and there's a queues thing, which is about events. I might not spend too much time talking about this, but this is the most exciting part for me going forwards because we're able to deal with real-world events, so MIDI controllers, open sound control messages on the network, and internal events as well. And this is a totally ordered internal event system which has pattern matching, and it's kind of like a tuple space, but instead of saying get foo, you say get foo at time t. Logical time t, and that's a really powerful way of deterministically working across threads so that if you have a multi-threaded system, and we'll see very quickly how that happens immediately, you can actually deterministically make sure that the same code produces the same music. And this is a really important goal, because if I make some cool music out of code, I want to be able to share it with you. Right? And if it's got threads in, and those threads have race conditions, and the results of those race conditions can choose different music, that's not cool, right? I want to be able to make sure that regardless of threads and what they're doing in terms of states, that we always get the same result. So this is interesting. I might have some time to talk about it more, but come and find me afterwards. Right, let's go. So the way to get started with Sonic Pi is that you just write the word play, you make it bigger, you choose a number, and ooh, there we are. How loud is that? It's not particularly loud. If I turn myself up a bit more. There we are, brilliant. Look at that, that's awesome. So, and this is important for schools because in schools the teachers have no time at all, and that's before they've even got the management sorted out and got the kids to be quiet, right? So all that stuff happens, and when they've got the kids quiet, they have to say their sentence, which is going to excite children to learn how to code. What would your sentence be? It's hard, isn't it, really? Is it open up Eclipse? So that's even Xcode or IntelliJ or any of these things, right? Or Emacs, right? No. So it needs to be something which is interesting and engaging. And so having the word play and the number 60, you can immediately make some results. And it's lovely to see the children's faces as they light up, that one simple line of code can actually produce some actual results which are meaningful to them. Not sorting algorithms, not binary arithmetic, not functions, not test-driven development, none of these things. making something which has an impact in their life, which is meaningful, which is not programming, right? That's the key. And music is one of many tools. I'm not saying this is the only approach. It's the approach I'm taking. The cool thing is we've got an example of syntax. We can talk about the fact that the mistakes are the default position of programmers because we're always in a state where the code doesn't work. That's totally normal because when it does work, you're on to the next problem. Right? And people have no idea about this. They think always that programmers are always working correctly, and we're not. So getting them to make mistakes, having the mistakes play, and cool, we've got nice ways to say, actually, did you actually mean this kind of thing, so we can hint towards the correct way of working. So yes, we did mean play, and lovely. And then numbers have a lovely property. They can go up, and they can go down. That's good, it's good. Sometimes I ask this to a bunch of Java programmers. They didn't know that, so I'm pleased that you're happy with being able to do this. And the beautiful thing about numbers, they're an abstraction, right? So they don't really mean anything until you relate them to the real world, right? And so lots of things in the real world can go up and can go down. Like I can jump, I can crouch, or notes themselves have pitch, and pitch can go up, or it can go down. Now let's test the bass of the system. Oh yeah, let's make that. Oh, yeah, this is lovely. Some schools I go to have the worst sound systems. And you just don't even hear this, right? So the last time I had a really good result like this was in a cinema. You can imagine that. And actually, there's the same Java programmers. They're in their comfy seats like this. Whoa! So that's awesome, right? So one line of code, we're having some fun. Now we've introduced options, so we can obviously start to modify the sound. Sounds have timbre. The timbre then is manipulated with these controls. And this is no different from a synthesizer you might buy in a shop with all those controls and knobs. Instead of knobs, we've got named parameters, or options, I tend to call them, because they're optional, because you do not need to use them to make a note. But when you want to actually start to change things, then this is available. Right, so, lovely. Now we get to the fun part. What might this do, right? This is interesting. As programmers, you might know, you might not know, you might have an idea. You won't have an idea probably unless you use the system. This, although it's a sequential piece of code, it is actually executing line 1 before line 2. Sonic Pi has a very strong notion of time. And you have to have a strong notion of time to make music, right? Because it's all out of rhythm and rubbish, right, if you don't have time. And so when you don't talk about time in Sonic Pi, everything happens simultaneously. So there we are at the same time. If I make this a bit bigger, higher, 50, maybe 62, maybe 62 plus, well, that's 62, oh, I can't type, plus 4, something like this. We start to do chords. And if you notice on the log on the right-hand side, it says at time 0, I'm doing both of these things. So that may be already a strange way of working, but it's actually super useful when you're making music. So don't talk about time, everything happens simultaneously. What's also interesting, before I start talking about time, is that you can change the sound. So if I use Synth Profit, I can play note E1 and have a long release time. Release is a fancy word in synthesizers. We have this idea of envelopes to talk about, actually, if I go into the documentation, there's a full tutorial, 60,000 words. It teaches you everything you need to know. And in here, there are pictures of envelopes. There's also another way to look at the documentation is to go to the website, and there's a web version as well. So let's look at the same thing here. There we are, slightly nicer. And we can start to talk about how the sound changes through time. So by default, the sound goes from quiet to loud instantaneously. That's like a clap. Yep. And then it fades out, typically over 1 second, unless you change it. So we can change that release time to be 8 seconds. And it's crazy, crunchy sound, right? We can also start to play with other options like the cutoff, which changes how much of the crunchy values are in there. So that's not so crunchy. Let's make it a bit more crunchy. Ominous, isn't it? What's happening? What's happening? Right, I can even take away numbers from symbols. It's fun. And so you can start to do this. Now, what's interesting, you might have noticed happening there. If you hear there's 2 sounds at once. Right? It didn't wait for the first time to finish before it introduced the second time. So every time it goes pink, it creates a new thread. So this is a multi-threaded system by default, by design. And that's really powerful. So already, with just 2 lines of code, I can start building ominous soundtracks where the sounds are overlapping and playing together. And this is one way of programming or live coding, is just by having a single line or a couple of lines and changing them. And if they're long, they'll overlap in interesting ways. And this is a beautiful thing. So it's important to point out that by default, it's concurrent. And I can create these things as we're overlapping, right? So we've got concurrency by default, which is fun. And you don't need to know about it. It just makes sense, right? That every time you press run, it just adds another sound and it layers it on top. The way to think about this really is like when I press run, a musician just magically appears, has these instructions to follow, he or she follows the instructions, and when they're completed, it disappears again, right? So we have these musicians just popping on stage and disappearing and reappearing. So there we go. So once we've got this, that's already fun, but maybe we want to make a rhythm or a melody. That's often useful in music. So let's go back to play 60 and play 72. To separate them, we need to sleep between them. Lovely, right? So that's fabulous, isn't it? Isn't that amazing? This is most of Western music. Seriously. And it shouldn't surprise you in the sense that logo, where we were drawing, the children to learn to code, Seymour Papert and Cynthia Solomon and friends, they were able to draw any picture with just pen down, pen up, rotate, and forwards, right? You can draw anything with those commands. With these 2 commands, you can make any melody, any Daft Punk bass line, any Mozart, any Bach. Okay, it's going to sound pretty crappy with the beeps, but you are able to reproduce it, and children do. And that's a lovely thing to see. And this is how to get them started. My 6-year-old niece, she was playing with this, and at the time when she was 6, and she'd written 30 lines of code. Now that's amazing. And she said, I'm not finished. And she was continuing on. So it was lovely to see that. So this is the way to get started. Now, this is also interesting because at this point, actually, when I built the system, the first version of the system in schools, teachers are very happy with this because at this point, we can teach most of the fundamentals of the UK's new computer science curriculum. Because it's very easy to add a bit of conditionals on here, a bit of repetition on here. You can start to use these things to explore what the basic principles of computer science are. So you can totally imagine repeating this 5 times. And this language is based on Ruby, so we have a nice way of representing that. You can do this kind of thing, or you can say, if some value is true, then do it, if not. So you can explore those things. But to me, this wasn't enough, right? I don't just want to just have some basic things. It frustrates the hell out of me that we have all these education systems to teach code that are beautifully simple to get started, but once you reach a level, like once you've mastered play and sleep, which is not long, frankly, is it? That's all you can do. And it has a glass ceiling immediately. And for me, I thought that it's an interesting challenge. Can I build a system that is simple enough for 10-year-old kids to use, and also actually the harder challenge is for teachers to use. And it's not that they're not capable, they just have no time, teachers. No time to learn anything. Certainly in the UK, they're so stretched, so stressed, so focused on making sure that the schools are able to jump up in the league tables and exams and tests and examiners coming in to test to see if they're teaching correctly. It's a very, very difficult environment to work in. That learning new things is incredibly hard. So teachers are actually the hardest and most important domain users to work on the system. But to me, that wasn't enough. I wanted to ask the question, could I get professional musicians to use the system? Right? And that sounds nuts. Why on earth would you build a tool that is good for education and good for professionals? That's crazy. Do one or the other. But what's a guitar? What's a piano? I can teach you how to play all the notes on a piano pretty easily, right? Super easy to get started. But is that where you stop? No. You can then learn how to do Mozart and Beethoven and Bach, and you can start to play ragtime jazz and all these amazing things because there's a whole culture of practice and there's a whole lot of experience in doing amazing things with the piano. It's the same as the guitar. Now, let's reverse that. Why would you bother playing the guitar? Is it because you're told to at school? Is it because it's a beautiful object? And some guitars are beautiful, but that's not necessarily what's going to excite you. It's because you've seen Jimi Hendrix. You think, what is he wearing around his neck? I need one of those, and I need to learn it. Or whatever your favorite guitarist is, or instrumentalist of any kind, right? And so having something which is good for professionals provides motivation for the beginners. This is why I am doing it. Now, in the UK, and I'm sure around the world, we're currently describing, and we saw earlier today, there is definite motivation to learn to program to get a professional job. That's very important. And we're, as an industry, we're crying out for more diversity, more people who wouldn't typically learn it, like weirdos like me, to get involved and do programming in a professional capacity. But to me, that is not the reason we should be teaching programming in schools. Because we don't teach sports in schools to make professional sports people. We don't teach history in schools to make professional historians. We don't teach mathematics in school to make professional mathematicians. We don't teach anything in school to make professional anything. It's just crazy. Of course, some sports people learning sports in school will become professional sports people, and that's awesome, right? And we should be totally supporting them and enabling them, and that's really very important, because they become the inspiring individuals which can make sure that new generations of sports people come along. That's very important. But it's not why we teach it at schools. We teach sport in schools because it's beautiful for the body, it's great for teamwork, it's great for synchronization, it's great for collaboration, it's great for physical exercise and health and so many important things that are beyond being a professional at X. And I think the same should be for learning to code. So if that's the case, what is the motivation we use to learn to code? And I don't think it is being a professional coder. I think that alienates a large number of people who just don't want to be professional. And it forces a very sort of elitist attitude. So that's not to say that we shouldn't support professional learning to code, that's very important, but at the same time, it doesn't necessarily involve everybody. And I think we need to get everybody doing a bit of coding, just like we get everyone to do a bit of reading and writing, right? That's just as important. It's not to say they're the same. And so, to me, we need to find these tools which will motivate, and I think music is a great way of absolutely doing this. So let's get cracking. So at this point, we have play and sleep. We can make music, we can make beats, and we can make melodies. It's very simple. But as programmers, I think the exciting thing is, what can we do with this? Where can we take it that's more interesting? Could we actually take this and challenge professional musicians and do new things, more exciting things, and take music into new places? This is not to say this is going to replace the guitar. Not at all. In fact, I actually have a fabulous collaboration with the guitarist where we work together, and I can code his guitar as much as he can work with the code as well. And that's really worth seeing. So the question is, what can we do with this? And these are questions now, at this point, we break away from the computer science curriculum, right? We're talking more about the music curriculum, and we're talking about music in general. What are musical tools that we can use that are exciting? Now, so the next thing to think about is, once we've got the synthesizers built in, what about samples? So often, certainly like hip-hop, for example, is based entirely around samples, manipulation of samples. So it's clearly important to me, and this wasn't in the UK curriculum for computer science, to play samples. So we have a bunch of built-in samples. You can play any WAV file, any AIF file, AIF or FLAC or OGG. And let's play a sample. Let's play the famous Amen break. Oh yeah, it's not loud enough. Can we make it louder, please? Yeah, right, okay. So we're in Bristol, right? We've got drum and bass kicking off. This is the famous track. Similar time, well, actually a bit earlier, NWA, straight out of Compton, used exactly the same sample, but what they did is they slowed it down to make it a bit more interesting and groovy, and so they played it half speed. Now you're rapping on top of this. That's important. And then you go back to London, and we're playing, what we're playing? A bit of jungle, and we're using the same sample, right? So at this point, people are, oh, okay, I can play samples. Of course you can manipulate them. But what did people do with these kind of things? So jungle wasn't just about playing the sample fast, it was about taking it and chopping it up and reversing it and doing all sorts of fun things. How do you take a sample and chop it up? Well, what they used to do is they used to use like these crazy graphical editors where they would actually by hand, find all the transients in the audio and move them around and copy and paste. And it took them weeks and weeks to make these interesting tracks. Painstaking, laborious work. Well, we've got code, haven't we? So wouldn't it be fun if I could treat my standard sample as an array, a list of drum hits? Yeah? Well, we can do that. We just use the onset option in Sonic Pi and actually ask for the first drum, or the second drum, or the third drum, or the fourth drum. Right? That's pretty cool. So it automatically does feature detection on the WAV file, returns all the starting and end points for those things, but this is something I can teach to a 10-year-old child. And the fun thing here is that we can really easily replicate some weird jungle music by sleeping for a short amount of time and or we're off, right? That's a lot of fun, right? And then if you want to, you can put a bit of envelope on that. 0 release time short, and then now kids would do this, it's a lot of fun, but they'd also, let's just comment this out, create another loop, and in there they would maybe, I don't know, make a bass line. So let's play Synth TB303, notes E1, release time short, sleep for, I don't know, let's make it a bit longer like this. Right, they've got that bass line, right? Ace. That's going to sound wicked with the drums. Let's crank it up. Where's the bass line? Now, I'm sure all of you can see why there's no bass line, right? But children can't, and teachers can't. And so you say to them, and the thing is, right, this isn't something that I thought was good. This is something that every child I've taught within a few hours asks. How do I play the drums at the same time as the bass? They all ask this question very, very quickly. And you say, you can't. You've got to wait till university before you can do threads. And they look at you like you're some sort of crazed idiot. And the problem is, you say to the teachers, yeah, I think we should be teaching threads, because the kids want to do this, right? And it'll engage them, they'll be excited, they'll keep being motivated. Because when you say you can't do something, they just look at something else. And that's not what we should be doing, right, when we're teaching computer science. We shouldn't be teaching people the same thing. We should be asking them what they want individually and making sure that the tools we use can support their expressions. Because what we're ultimately doing is giving people new tools to express themselves. And code is a fabulous way of doing that. So saying no is not an answer. But the problem is you go to the teachers and the teachers say no. Because they're focused on making sure that they get good scores when the examiners for them come in. And their scores are based on whether they're teaching the curriculum correctly or not. And if it's not in the curriculum, then they don't get any extra points for teaching stuff which is not in the curriculum, regardless of whether it helps the children engage, regardless of whether it actually gives them tools to become more creative coders. Right? So this is a problem. And the cool thing about being programmers is we can cheat. We saw earlier that cheating is super important. The goal is cheating, right? The goal is, if you don't cheat, then you're not being professional. If you don't ask the right people, you're not. And so this is why I fundamentally disagree with exams in many ways, because they don't support cheating, and they don't support collaborative working and changing the rules. So we should be able to change the rules. So what do you do when you can't do threads with loops? You create a new kind of loop that is threaded. And that's what I've done, right? So I don't teach this, I don't talk about loops, and in fact, if you see this kind of code in Sonic Pi, just tell people don't do this. You want to use the live loop. It's got a way cooler name, for starters. And when you run it, it gives you an error, right? So it's not quite the same. It says, let's get rid of this documentation down here, sorry. Boop. It says, live loop needs to have a unique name. So live loops are band members. Right? So I have a bassist and I have a drummer. Right? So let's give them some names. So what should we call the drummer? Let's call the drummer, what should we call? Peter. And let's call the bass player Fiona. Right, so now we give them names, we can run the code. And it's working, right? Awesome. The problem is, though, you get pretty bored of that pretty quickly. Because loops they loop, don't they? They just keep going. And I mean, it's great to start with, but after a while, you start getting a bit bored of the music. So what do you want to do? Well, I want to change it. Maybe that note is a bit too long, so I'm going to change it to be a bit shorter. Right, or maybe I want to have like a higher note. Right, yeah, that's quite good. Or maybe I want the cutoff to be like a random value between 70 and 130. Yeah. Or maybe I want to actually have it as fast as this. Right, you can see already it's quite fun to explore these things by just changing the numbers and hearing it and changing it and hearing it, which is great for me, but it's rubbish for you. Because if you want, I mean, obviously you're all seated, so that's a problem. But let's assume that you weren't seated and that you were in a party mood. I mean, are you in a party mood? Yeah, well, that's rubbish. You will be later. If you're in a party mood, you do not want the DJ or the performer or the band to stop every time they want to change something. It has to be able to change whilst it's still playing. Otherwise, it's not a good performance. I mean, obviously, you can imagine performances that are very weird and esoteric and acousmatic and whatever that do that. But in general, you want to be able to keep the music playing. You want to be able to comment things out, right? Like have them comment it out or bring them back in again. Make them quieter. So this live loop allows you to change it whilst it's running. Fun as hell. And this is what engages people. This is not on the curriculum, but it's something that actually people can start tinkering with, and it's addictive, and it's something that induces flow, and it's just fun. And I spend hours every day just doing this. And I really recommend you do too. Because, right, if for anything else, it'll give you a tool to make more friends. I mean, how many of you, I say this all the time in most conferences, it's just an amusing thing. How many of you go to parties and struggle to talk to people because when you say you're a programmer, it's the end of the conversation? It's true, isn't it, right? And so, I don't say that anymore. People ask me what I do, I say I'm a musician. Oh, wicked, what do you play? Code. And they're like, whoa, but at least now having a conversation, right? And you can too. And this is the cool thing is like, I don't know how many people who struggle to talk about how you had an issue with a Docker container that had a serverless, Nginx, Apache, whatever configuration. Like no one wants to listen to that, but they want to listen to this. And so this is a way of getting involved and getting talking and broadening the conversation beyond the people like yourselves who themselves fell into programming. Right? That's great that we have people who themselves want to become programmers, but if we want to diversify our communities, we need to be appealing to the people who wouldn't necessarily themselves choose to be programmers. And so this is, and a good test of that is, can you have a conversation with them at a party? And I think this actually passes that test. In fact, what you can do is you can become the party by being a coder, which is what I'm going to do later. And that's amazing. I was randomly in a nightclub in Berlin, a big warehouse, and for some reason, I had synthesizers in my laptop in my bag, and I was completely concerned about this. I've got a few £1,000s worth of things in this bag, because I was giving a workshop earlier at Microsoft headquarters. And the DJ didn't turn up. It was like 3 in the morning, and my friend, who knows the guy who organizes the club, said, do you want to play? And so I cracked open my laptop, coded the nightclub. It was amazing. It was the best experience I've had in a very long time. So you can become the party if you can live code. Right, I've got 10 minutes left. What else can you do? The fun things, let's go back to this. Because this pattern doesn't just work for drums. Watch this. You can slice up anything, right? Any sound and play with it. So any sample you play with and work with, you can work with. That's fun. What about another thing that children ask all the time is like, I'm making music, this doesn't sound very good. Like, okay, well, what do you mean? Well, I want it to sound roomy and big, and when I listen to my music, it has this beautiful sound. Like, if I'm making music in this kind of room, it has that kind of sound, but you don't have access to this kind of room in a classroom, do you? And so you say again, you can't do that because it's not on the curriculum. That's obviously a rubbish answer. So you sneak these things in, right? So it was really important to me to be able to allow children to write effects. And so if I have, let's think of like what shall we do? Let's do 8 times do, and let's play notes, I don't know, scale, type scale, right? E1, minor, pentatonic. Do you see how I switch those letters around with a Control T from Emacs? Choose, release time short, seat for 1, 2, 5. That's not very good, is it? There we are. There's my little ditty. And actually, we've got the reverb from this room already. But let's crank it up even further. So what we can do is, and I won't go into detail about this, I gave a talk at Strange Up a few years ago where I actually talk about how this works. It's super interesting. But in terms of actually, because it's good to talk about the technologies about these things, but it's also really much better to talk about how to use it and what to do. And so in my head, what I really want to do is create a sort of another lexical closure which describes the area of the code I wanted to affect with some effect like a reverb or distortion. So this is the kind of thing I had in my head. Like between these do and end blocks, I want to be able to have this code with reverb. So you can do this by adding with effects, the front, choosing the effect, reverb. And reverb supports different options. So the room size being 1 is the most reverb. And so by doing this, I can or I can crush it, or I can echo it. And you can start to add these effects, super easy. Now, the implementation of this is the hardest code I've ever written in my entire life. And I'm super happy to talk to you later about how this works and why it works. But the scheme of the problem is that essentially you have to set up the effect, so the echo effect. You have to ensure that all the audio inside of it reroutes to that. But then the hardest bit is you have to then tear down the echo when it's finished. And the problem with this is that you've got to basically observe and watch all the synthesizers that are created in the code block, wait for them to complete before you can kill it. But also, the code block can start spawning threads arbitrarily. So you have to wait for the threads to complete, and their threads, and their threads, and their threads. So you have to sort of manage the whole network of threads. And to be honest, I'd have had a much better time not working with Ruby, but working with Erlang to do this. And I wish I had done, and I probably should in the future. So if you want to re-implement this, do it in Erlang. But there we go, right? So we were able to do this, and we can obviously nest these things. So that's FX, crush it. Oh, that's horrible. So it's very easy to make sounds which are hideous. But you can start to see where you can do this. And this is fun because I can put any code in here, and it will be echoed and crushed. And I can also do something like this, which I'm not going to run because I haven't got my sound card plugged in. But if I have a sound card plugged in and I plug a guitar into this, right, now I have a guitar effects chain. Right, and my guitarist friend, Ben, he can play his guitar, and it's got echo and crush on the guitar, and that's super fun to see. And when we give talks to kids, we gave a talk at the Big Bang Fair, the UK's largest STEM fair, we give 8 separate talk performances. One of the fun things to do is just to do live audio, and he's playing a clean guitar sound, add reverb, add distortion, and suddenly he's in this sort of rock mode. And that's really fun to play, and you can live code all this stuff and modify it in time and work with it. It's really a lot of fun. Right, what else should I talk about? Let's think about this. Well, it's worth actually just spending a little time just flicking through these tutorials. So you can make beeps, you can change the synthesizers, you can switch the synthesizers, you can change the envelopes, you can play with samples. A fun thing to do with samples is to work with external samples. So you can obviously use the built-in ones, but if you have a directory of samples, let's find a directory of samples. So sam, node, samps. Here's my directory of samples. Let's find like a house samples. I've got some loops in here. I've got some bass lines. So let's drag one of these things. So I can go here. I can write sample. I can then drag this sample across, and then get some sample going. Cool. So I can work with external samples, super easy. But that's a pain in the bum to write all that stuff. And also, if I wanted to work on the next sample in a directory, I needed to go and find it and find the name of it and figure it out. And that's annoying as well. So it's actually much more fun. First of all, I'll just give it a name. That works. And then, actually, instead of using the file name, it's much more fun to use the directory name. get the same results. Well, how does that work? What does that mean to play a directory? What it does is actually it will then look in that directory for all the basically all the music files, sort them alphabetically and play the first one, which may or may not be what you want. But once it knows the list of all the files in that directory, and you can glob this, so you can do nested directories totally easily, you can then use filters to say, actually, I know that my folder structure here has the BPM and the key, so I can find the first one that's in F minor by just saying comma F minor. Oh yeah. Oh, I find the next one. Right, and I can actually play two of them together. Right, so you can start to play with these things, and you can use substring matches, regular expressions. You can even use an arbitrary lambda function, which will take in the list of options, and you can return a new list of options. So you can even insert things if you want to. So you're free to really play around with this stuff. It's a lot of fun. And once you've got that, then you can start to use the live loop to make some music. So a live loop, call it foo, bring this down here. And let's just use one of these. I have loops bass, but I also have loops drums in here. That's fine. I haven't got any 120, that's good. So that I can then say B is drums. And then here I can then sample A and sample B. And I can make sure they both have 120 in the string name. So that's good. And then we can, oh, then we've got an error because I haven't got a comma. Where's the drums? Oh, I don't have an F minor in the drums. Let's get rid of that. Drums do not have a key. Right, we're going. Oh, it stopped. Can anyone see why it stopped? Because obviously if you try and loop something with no sleeps in it, you're essentially asking the computer to spin it around infinitely, number of infinite times in 0 time. That's just nuts. So it actually tells you can't do this. So live loops need to sleep or sync. And syncing is working on external events, which I haven't got time to talk about. But here I can now sleep for 8, and now we're off. And now obviously I change the numbers, and the next time round, we're off, right? We're coding music. And this is a great way to get started, just using existing samples which sound good, find the ones you like, and then just start messing with them. And this is a very simple pattern that you should learn, and it's just fun just to play with and change and tinker with this stuff. I think, how many minutes have I got left? No minutes. Right, okay, perfect. So let me just give you the website to go to again, sonicpi.net. Please download it, please play with it, please share it with your friends, with your children, with your grandparents, with your parents, and with their friends and their children and their grandparents. Spread the word of creative coding. Get everyone coding a little bit. And then some of them will become professional programmers, win, and just most of them will be able to have a conversation with you at parties. And that's what we're ultimately about, is trying to affect the world in a good way and get more people to understand that coding is the most creative and powerful tool we've ever made as humans. It's another language, just like poetry, except it can do stuff. That's wicked. And you can write poems with code, so that's awesome as well. But you can also make code that can actually affect the real world. And we should be trying to find ways to empower people to change their world in ways which are meaningful for them. And the important thing about this is those ways don't always have to make money. They don't have to be about industry. They don't have to make rich people richer. We should make people be more expressive, and we should be using our skills as programmers to enable that in priority over companies, in my opinion. So hopefully some of you might agree with that and hopefully spread that word. And if you don't, then come and have a chat with me later, and I'd love to hear your opinions about why that's different. And it's important we all have our ideas and share them together. So thank you very much for your time. I'm going to be playing here later tonight at about 7:30. So there's going to be 2 parties. There's going to be one over there where there's going to be drinks and some nibbles for chit-chats. Go over there if you want to do those things, initially to start off with. But then come here, 7:30, for some crazy music where we're going to do some dancing, hopefully. Thank you very much for your time.
I'm going to ask one quick question, but first, thank you so much. That was my favorite live demo of today, so appreciate it. So why did you choose integers for the notes, and what does 0 represent?
So in the music world, there's an already existing idea, certainly in Western music, about pitch. and there's numbers on a piano. These are what we call MIDI notes. And so the integers represent MIDI notes on the piano. But you do not need to use integers. I didn't show you, but you can use floats. So you can say, play note 60.4 to make a note in between notes. The nice thing about integers and MIDI notes is it's a linear scale, not logarithmic, which is what Hertz is. So it's much easier to reason about as humans and easy to teach to kids. So it's not integers, it's floats. I just happen to use integers on stage.
Cool.
Yeah. And 0 is a very low note. Yeah. It's a valid note, it's just very, very low. Yeah. You heard how low 30 was. And the speakers won't be able to reproduce 0.
We can try later.
Yeah, we could try it later, yeah.
Last question.
Yeah.
Are you going to play Lollapalooza next year?
I'm sorry, what's the
Are you
question?
going to play Lollapalooza next year? It's the big Chicago music festival.
If they invite me, I'd be delighted to go, yeah.
All
I
right.
performed at Moog Fest in Raleigh, Durham, and I got into the Rolling Stone magazine. They said I transcended the present. And I'm going to perform next year at the Royal Albert Hall. That's pretty cool. So yeah, so I'd love to. Yeah.
So then the follow-up is, what's your DJ name?
Sorry?
What's your DJ name?
My DJ name is Sam Aaron. Super easy to remember. I've struggled with that for a while, and I just felt pretentious coming up with a different name. So why not use my own name? Quite like it. Simple.
We
Yeah.
all know it now. Well, thank you so much, Sam. It's time to party, so feel free to go grab a drink and some food in the Lakeview Terrace. But as you leave, one last round of applause for Sam.